So using the formula of delta theta all over delta V is equal to 2kp V plus 2VE over kp, you will be able to find for the value of M. So just press on your calculator the shift stat, and then the calculator will ask for the values of Y. So this is just the same. This equation is the same as Y is equal to mx plus b. So the Y here is the delta theta all over delta V, and the x is the average V. So I calculated for these values, and then for the average I also calculated this one, and then finding for the slope. So the value of the slope is this one, and then equating the slope to this part of the formula, you will be able to find for the value of kp. So the value of kp is this one, and then now we will now be able to solve for the pressure or the delta P. So the formula is kp is equal to 2 times the area squared times delta P times G sub C all over Cs times alpha times viscosity. So all of that are given, and then just equate kp to this formula. So the value of P is 6192.17 kilopascal. And there you have it, the value of the pressure. Next problem is about industrial centrifuge. So the problem reads: a solution containing particles with density at 1.8 gram per ml is to be clarified using an industrial centrifuge. The solution has a density of 1.2 gram ml and a viscosity of 0.0009 pascal second. The centrifuge has a radius of 0.025 meter and the liquid layer is 0.006 meter from the axis and has a height of 0.25 meter. Calculate the critical diameter at the exit point. It will be set at 15,000 revolutions per minute and has a flow rate of 4 times 10 to the negative 5 meter cube per second. So the density just changes to kilogram per meter cube, and then these are all the givens, the R2, the R1. R2 is the radius of the whole centrifuge, and then R1 is the distance of the liquid from the axis, and then B is the height or the depth. N, so change this to rad per second, so we will have the value of 1570.7963 rad per second, and then the value of QC is also given. So the working equation is QC is equal to W squared, so the dPc squared, or the this is the critical diameter, then density of the particle minus density of the solution all over 18 times viscosity times ln of 2 r sub 2 all over r sub 1 plus r sub 2 multiplied by pi times the depth or the height, quantity r2 squared minus r1 squared. So just insert all the given, then leaving the dPc unknown. So we'll be able to get the value of dPc to be 6.7254 times 10 to the negative 7 meter. Then CPF preceded by CRF. So this has many formula, so be sure that you're very familiar of the many formulas under CPF and CRF. So always keep in mind that CPF and CRF are two different kinds of filter. So the problem reads, determine the optimum capacity for a leaf filter operated by CPF preceded by CRF. At the end of the CRF, 3 meter cube of filtrate are obtained after 45 minutes. The cake is washed with 45% of the filtrate volume. The cleaning will take about an hour. So assume that the value of Rm is 0. So these are the given. So Vr is equal to 3 meter cube, theta R is equal to 45 minutes, Rw is equal to 0, V is equal to 0. So there is a formula there. Vw all over theta W is equal to K all over Bf plus Ve. So we know that Ve plus Vf, so this is 0. So we will now have the value of Ve. So Vw is equal to 0.45 Bf. And then other formula here is K is equal to 2Vr, quantity Vr plus Ve all over theta R. And now we have the value of this one, Vr and theta R. So just kindly put all the data here. Then you will have the value for K, so 0.4 meter cube per minute. So substituting this one to the formula derived, so we will have 0.45 Bf all over theta W is equal to K to Bf. So theta W is now equal to 2.25 Bf squared. And then given again the time for cleaning, which is 60 minutes or 1 hour. So Bf squared minus Vr plus 2Vc Bf minus Vr is equal to K theta F minus theta R. We now have the value of K. And then just simplify the equation. We'll now have Bf squared minus 9 is equal to 0.4 theta F minus 45. Bf squared minus 9 is equal to 0.4 theta F by distributive property minus 18. So simplifying the formula, we will now have theta F is equal to 2.5 Bf squared plus 22.5. So now we are able to find for the value of theta F and theta W. So the formula for the capacity is equal to Bf divided by theta F plus theta W plus theta C. So substituting all the values of theta F, this one is the theta F, this one is the theta C, and then this one is for the theta W. Just plug in all the values in the general formula. So we will now have y is equal to Vf divided by 2.5 Vf squared plus 22.5 plus 2.25 Vf squared plus 60. And then y is equal to Vf, by simplifying this, all over 4.75 Vf squared plus 82.5. And then, applying differential equation, we'll now have d1 over y is equal to 4.75 plus negative 82.5 Vf squared. So, simplification, we will now have 82.5 is equal to 4.75 Vf squared. So in this, we will now have the value for Vf. So Vf will be used in able to solve for the capacity, filter capacity. So R double is 0, V is 0. So now, we now have Vf, which is 4.18 meter cube. So 4.18 meter cube divided by 2.5, this is the Vf, so 4.18 4.18 raised to 2 plus 2.25, 22.5 plus 2.25 times 4.18 raised to 2, this is raised to 2, I'm sorry, plus 60. So the answer here is 0.0259 meter cube per minute. So just change this to meter cube per day. So multiply by 60 minutes per hour, then 24 hours per day. We will now have the capacity, filter capacity of 37.35 meter cube per day. So there you have it, all the problems. Thank you for listening.